Welcome to Math with Easy Logic. In this video we'll talk about logarithms, and I've prepared some exercises for you that we're going to solve together. And if you want, you can pause the video at any time, try to solve them by yourself, and after come back for the solution. Before we start the video, I'm going to show you right now the log laws, and those will be very useful during the video. Alright, so we'll start off by simplifying this first expression. When simplifying an expression like this, we'll just multiply the first term here with each of the terms inside the parentheses, and that just works by adding the exponents. With the next one, we can leave the 2 in the front. And then minus 3x to the power of negative 1/2 minus 1/2. Alright, we can simplify this. The first one will be x to the power of 1 plus 2x to the power of negative 1/2 plus 1/2 is 0, and then minus 3x to the power of negative 1. Anything to the power of 0 is always 1, so 2 times 1 will be 2. X to the power of 1 is just x. So this whole expression will be x plus 2, and then x to the negative 1. X to the negative 1 will just be 1 over x. Alright, and that's your final simplified expression. Let's move to the next one. We just have to find x in this example. So what we can do here is just take the logarithm. Let's just take base 10 basically. Okay, and now we need our log laws. So if you have a power inside of the logarithm, you can just pull that to the front. So you will have 3x times log 2 is equal to 2x minus 1 times log 3. Okay. Now we'll factor out the x. Okay. Now put this expression, this one over to the right side and log 3 to the left side, so that we have the term with the x on one side. So it will be x 2 log 3 minus, and then also x, so we just keep it here in front, 3 times log 2. Alright. And now this side we can still simplify. And log 2 log 3 will be the same as log 3 to the power of 2 minus log 2 to the power of 3. And that will be the same as 9, 2 to the power of 3 is 8. Now we can simplify this even further using our log laws. Log 9 minus log 8 is the same as log 9 divided by 8. And now just multiply it over to the other side so that we can eliminate the x. Alright. If we want to get a more precise answer, you can just type this into the calculator and get the answer from there. Or rewrite it, but that would look a little bit complicated. If you want to rewrite it, you can use the 7th log law on changing the base, and that will be log to the base of 9/8 and 3 here. But this way is also fine. Alright, let's go to the next one. In this case, we can use our log laws again. Let's take to the base of 10. Okay, now this part here, the exponent, goes in front, and we're left with log 3. And then this one, first let's write it as 2 expressions. So log 5, and then if you have a times inside of the log, you can just write it as plus another log of 36 to the negative x. Alright, now negative x just goes in front as well. And this one will be log 3 plus x log 3 goes to log 5 plus minus x log 36. Okay, now we will put both the x's on one side again. So that's x log 3 plus log 36 equal to log 5 minus log 3. Okay. If you have a plus, you can multiply these two together. So x log, and then 3 times 36 is 108 is equal to, and log 5 minus log 3 is log 5 over 3. Okay, now we can divide the whole expression by log 108 to get x on one side. That will be log 5/3 divided by log 108. And if you want, you can rewrite this using the 7th log law as the logarithm to the base 108 of 5/3. Alright, that's your final answer. If you want, you can of course also use the calculator to find the decimal. Alright, I'll have 3 more examples here. Log base 3 of 12 minus log base 3 of x equals log base 3 of 3. First combine this left side here to make one logarithm. It will be log base 3 of 12 divided by x equals to log base 3. Okay, and now we can eliminate the log 3 because it's on both sides. If we just have 3 to the power of log base 3, 12 divided by x, and the same on the side, and then these two here just cancel out, and you are left with 12 divided by x is equal to 3, this 3 here. Now 12 is equal to 3x divided by 3, so 4 is equal to x, and that's your final answer. Alright, let's do the next one. Here we can apply this rule too. Just have a 7 to the power of log base 7 on both sides. That way we'll eliminate the log and be left with negative x minus 1 is equal to x. And we can add x on both sides. Left with negative 1 is equal to 2x. So x is equal to negative 1/2. That's it. Alright, next one. Here we can take the third logarithm. So 5 minus x. And this one will just cancel out if we take the third logarithm. Or logarithm to the base 3. Base 3 of 100. Okay. And now x is equal to 5 minus log base 3 of 100. Okay. Right. Let's do another few examples here. 2 log x equals to logarithm of 81. So that means that log of x squared is equal to log 81. If we have 10 to the power of log, these two here cancel out, and we'll be left with x squared equals to 81. Now x can be positive or negative square root of 81, which is 9. And now here you have to be careful. If you look at the log, you might know that x always has to be bigger than 0 from the definition of a logarithm. So therefore our solution can be only positive, so we have x equals to 9 and not negative 9. Alright, next one. Log base 3 of 8x plus 9 is equal to 4. So that means that 3 to the power of 4. So if we apply the same rule here, is equal to 8x plus 9. Now 3 to the power of 4 is the same as 9 to the power of 2. Or let's write it like this first. 3 to the power of 2 times 2. And that's the same as 3 to the power of 2 to the power of 2, which is 9 to the power of 2, and that's 81. So 8x plus 9 is equal to 81. Subtract the 9, 8x equals to 72, so then x is equal to 9. Okay. Next example. Here we have both to the base 2, so we can combine these two terms, which will be log base 2 of x plus 1 divided by x minus 1 because of the minus here. And that will be equal to 3. Now we can take both to the base 2. And these two here cancel out again. So we have x plus 1 divided by x minus 1 is equal to 2 to the power of 3, which is 8. And we'll multiply this term here to the other side. So then we have x plus 1 is equal to 8x minus 8. Now subtract an x on both sides and add 8. So 9 is equal to 7x, which means that x is equal to 9 divided by 7. Alright. We have 3 more examples. They just have log, so that's automatically base 10. So we can combine these terms again. That will be log x plus 2 times x minus 2, because they're added together, equals to 1. So now can have both here a 10. 10 to the power of 1 is just 10. So x plus 2 times x minus 1 is equal to 10. And now we just expand and simplify this expression. Get x squared plus x minus 2 is equal to 10. Now subtract the 10. X squared plus x minus 12 is equal to 0. Now we can factor this. So which two numbers together multiplied together give us negative 12, and added together give us positive 1. And that will be x plus 4 and x minus 3. 4 minus 3 is 1, and 4 times minus 3 is negative 12. Equal to 0. So our x1 equal to negative 4. Our x2 is equal to 3. And now we have to check again for the logarithm laws. So we know that what's inside the parentheses here can never be smaller than 0. So x minus 1 has to be bigger than 0. And if you plug in negative 4, you will get negative 5, and that's actually negative, so you cannot have this as a solution. So this one here will be your final solution, x is equal to 3. Okay. Next example, we have everything to the base 7, so we can simplify this again. And that's x times x minus 5, so x squared minus 5x. And on the other side we have just the same expression, x plus 12. Right, now we can eliminate the log. We'll be left with x squared minus 5x is equal to x plus 12. So x squared, now subtract x from both sides, so negative 6x, and then subtract 12 is equal to 0. So we'll just use the quadratic formula, which is x is equal to negative b plus minus square root of b squared minus 4ac divided by 2a. So in this case our b is negative 6, so negative times negative is positive, minus square root of 6 squared, well, negative 6 squared, so that's just 36, minus 4 times 1 times negative 12 divided by 2 times a is 2. So here we have 36 and then plus 48. That's equal to square root of 84. Okay, and 84 is equal to square root of 2 times 42 equal to square root of 4 times 21. And 4 we can simplify to 2, square root of 21. So that's equal to 6 plus minus 2 square root of 21 divided by 2. So now our x is equal to, we can simplify this here, equal to 3 plus square root of 21. Now notice how I'm not writing the minus here. It's the same as earlier. If we use the minus, the expression will be negative inside the parentheses, which is not allowed. So that's our only solution. Alright, next one. Let's rewrite the right side. It's log x 5 to the power of 9 equals to log base 5 of x. Now we can use our 7th log law and simplify this to, let's just take log to the base 10 of x divided by log to the base 10 of 5 is equal to log to the base 10 of 5 to the power of 9 divided by log x. Okay, so now multiply this over. Log x all squared equal to log 5 times 9 times log 5. And now rewrite this right side again, which is 3 times log 5 all squared. Okay, and now we can eliminate the squared, so we're left with log x is equal to 3 log 5. And rewrite the right side again, just log 5 to the power of 3, and that's also 125. And now if we take everything to the base 10, the log will be eliminated. So now x is equal to 5 to the power of 3, which is equal to 125. Okay, let's do the last two examples. So log base 4 of x plus log base 2 of x equals to 3. So let's keep the base 4 here. And then this one we can rewrite as log base 4 of x divided by log base 4 of 2. It's to 3. Okay, so log base 4 of 2 is just equal to 1/2, because 4 to the power of 1/2 is equal to 2. So we have log base 4 of x plus log base 4 of x divided by 1/2. And if we take the reciprocal, it's just times 2. So log base 4x plus 2 log 4 of x equals to 3, which means that log 4 of x plus log 4 of x squared is equal to 3. Now we can combine these two. Log base 4 of x to the power of 3 will be equal to 3. So if we take everything to the base 4 here, x to the third is equal to 4 to the power of 3. And if we take the third root of both sides, then x is equal to 4. Right, let's do our last example. We can take the log of both sides again. Times 5 to the power of 4x plus 3 is equal to log 10 power of 2x plus 3. Let's separate the left side. Log 4 to the power of x plus log 5 to the power of 4x plus 3 equals 2, and then here we can take the exponent and put it in front. Log base 10 of 10, and that's just 1. So we can actually take this out. Alright, so that's x log 4 plus 4x plus 3 times log 5 equal to 2x plus 3. Now we'll put all the x's together. X times log 4 plus x times 4 times log 5 minus 2 because of this term here is equal to 3 minus, now we have to subtract this term, 3 log 5. Okay, I can simplify this here. X times log. Alright, maybe it's easier if we keep our log 10. So let's write it again. Plus log 5 to the power 4 minus log 10 to the power of 2, which is the same as just 2. Is equal to 3 minus log 5 to the power of 3. Okay. So now let's combine the logs here. Log 4 times 5 to the power 4 divided by 10 to the power of 2. And the 3 is also again the same as 3 log 10, because that's just 1, minus log 5 to the power of 3. Alright, let's simplify this here again. X times log, and this is 100, so we can just divide 100 by 4, which is left with 25. 25 is 5 to the power of 2, so we're left with 5 to the power of 2, which is 25. It's equal to log 10 to the power of 3 minus log 5 to the power of 3 is equal to log 10 to the power of 3 divided by 5 to the power of 3. And this part here is just 1000 divided by 125. If we divide this all by 5, we're left with 200 divided by 25. By 5 again, it's 40 divided by 5. 40 by 5 is just 8. So this is log 8. X equals to log 8 divided by log 25. And that using the changing the base rule, we can simplify this now to log base 25 of 8. Alright, that's it for this video. I hope that you've been able to solve these questions or gotten some answers from the video. And I'll do another log video soon, so stay tuned for that.